Imagine standing at the edge of the Indian Ocean, looking at the calm waves of the Thane Creek. You wouldn't think that 54 meters directly beneath those waves, a massive, 13-meter wide robotic beast is chewing through solid volcanic rock. This is the Thane Creek undersea tunnel, the most dangerous and technically challenging part of India's first-ever bullet train project. We are talking about a 7-kilometer stretch of pure engineering madness, where the pressure of the sea above is constantly trying to crush everything in its path. This $15 billion project isn't just about speed, it's about conquering the deep. If India succeeds, it joins a tiny list of nations that have mastered the art of underwater high-speed rail. But one mistake, one crack in the tunnel lining, and the entire 21-kilometer section could be flooded in minutes. Today, on the Global Build, we are declassifying the blueprints, the risks, and the secret technology behind India's underwater beast. Hello everyone, and welcome back to the Global Build. Your response to our SkyTrain and Green Wall videos has been phenomenal, and it's clear you want to see the future of mega infrastructure. Today, I'm going to brief you on a project that will change the face of Indian transportation forever. The Mumbai-Ahmedabad high-speed rails underwater tunnel. To make sure you understand the sheer scale and the danger involved, I have calculated this investigation into 5 extremely detailed parts. Part 1. The Mumbai-Ahmedabad corridor strategy. Why India is spending billions on Japanese Shinkansen technology. For Part 2. The 21-kilometer subterranean maze. We'll explore why engineers chose to go 114 meters deep under Mumbai's skyscrapers. Part 3. The Afcons engineering marvel. A technical breakdown of the 13-meter Slurry Shield TBMs. Part 4. The 54-meter pressure test. We discuss the seismic risks and the corrosive power of salt water. Part 5. The global verdict. A comparison with China's rail network and India's future as a superpower. I urge you to watch until the end. Part 1. The Mumbai-Ahmedabad corridor. The global vision. The Mumbai-Ahmedabad high-speed rail is more than just a train. It is an industrial revolution on tracks. Stretching 508 kilometers, it connects India's financial capital, Mumbai, with the textile and industrial giant, Ahmedabad. Currently, a train journey between these two cities takes over 7 hours. The bullet train will scream through this distance in just 2 hours and 7 minutes. India has partnered with Japan's JR East to bring the E5 series Shinkansen technology. This is the same technology that has operated in Japan for over 50 years, with 0 passenger fatalities. But India isn't just buying the trains, they are building a local ecosystem. Thousands of Indian engineers are being trained in Japan to learn the precision required for high-speed rail. This corridor is just the beginning. The government has already planned 7 more corridors connecting Delhi, Varanasi, Kolkata, and Hyderabad. The success of the 7-kilometer underwater tunnel is the ultimate stress test for India's future as a high-speed nation. Part 2. The 21-kilometer subterranean maze, defeating the density. While 92% of the bullet train track is elevated on high-standing piers, the entry into Mumbai was a nightmare for urban planners. Mumbai is one of the most densely populated cities on the planet. Building an elevated track through the heart of the city would have required demolishing thousands of buildings and cost billions in land acquisition. The National High-Speed Rail Corporation made a bold move. They decided to go underground for 21 kilometers. This tunnel starts at the Bandra Kurla Complex, BKC, the financial heart of the city, and goes all the way to Shilpata. But it's not a straight line. The tunnel has to navigate beneath existing metro lines, skyscrapers, and a maze of colonial-era sewage pipes. To avoid all these obstacles, the tunnel dives to a maximum depth of 114 meters. That is like burying a 35-story building underground. But the real challenge begins as the tunnel approaches the coastline, where the hard city rock turns into the soft, unstable mud of the Thane Creek. Part 3. The Afcons engineering marvel, the giants beneath. To carve through the seabed, India is using 3 of the largest tunnel boring machines, TBMs, ever seen. These machines, handled by Afcons infrastructure, are absolute giants. Each TBM has a diameter of 13.1 meters. To give you an idea, so that is wider than the tunnels used in the English Channel. These aren't just drills, they are automated factories. The specific technology used is the Slurry Shield TBM. Standard TBMs would fail under the Thane Creek because the soil is a mix of hard volcanic basalt and soft marine clay. The Slurry Shield pumps a pressurized mixture of bentonite clay to the front of the cutter head. This liquid pressure creates a shield that balances the weight of the ocean above, preventing the tunnel from collapsing during the dig. As the machine moves forward, it installs 2-meter-wide, high-strength concrete segments. These segments are bolted together and sealed with specialized waterproof gaskets to ensure that not a single drop of seawater enters the tunnel. And this is precision engineering, where every millimeter counts. Part 4. The 54-meter pressure test, risks and seismicity. Building 54 meters below the high tide level comes with terrifying risks. The first is corrosion. Salt water is the enemy of steel and concrete. To prevent the tunnel from rotting from the outside, engineers are using a special, high-density concrete mix that is resistant to sulfate and chloride attacks. The second major risk is seismic activity. Mumbai is in a moderate-risk earthquake zone. For a train traveling at 320 kilometers per hour, even a tiny vibration can cause a derailment. Therefore, the tunnel is equipped with seismic dampers, flexible joints that allow the tunnel to sway slightly during an earthquake without cracking. Additionally, there is the piston effect. When a train enters a tunnel at 320 kilometers per hour, it pushes a massive volume of air ahead of it, which can cause a loud sonic boom at the exit. To solve this, the 7-kilometer underwater tunnel has a larger diameter and specialized ventilation shafts to manage air pressure, ensuring a smooth and silent ride for the passengers. Part 5. The final verdict, the 2028 reality. When the first bullet train passes through this tunnel in 2028, it will mark India's arrival on the global stage of extreme engineering. This 7-kilometer underwater stretch is proof that India can tackle projects that were once reserved for only the wealthiest nations. It will create a bullet train economy where people can live in Ahmedabad and work in Mumbai, effectively merging 2 massive cities into one economic powerhouse. Comparing this to China's 40,000 kilometers high-speed network, India has a long way to go, but the quality and safety standards of the project are setting a new global benchmark. What do you think? Is the $15 billion investment justified for this technological leap, or should India have focused on its existing rail network first? Let me know your thoughts in the comments. If you enjoyed this research-heavy documentary, please hit that like button and subscribe to The Global Build. We are documenting the megaprojects that are quietly reshaping our planet. Thank you for watching until the very end. I'll see you in the next project.